Hello to everyone. In this video, let us discuss what is that kinetic molecular theory of gases. So this is one important topic in states of matter. So in that, what are the postulates to see here? The first one is here, gases contain tiny and discrete number of particles. Those are called nothing but molecules. And molecules move randomly in all directions with high velocities. Gaseous molecules move randomly in all directions with high velocities. And among that movement, due to the collisions, now what happens here? They exert some pressure due to the collisions among them and also with the walls of the container. They exert some pressure. So due to that, pressure is exerted. And here another important thing is here. What is that? These collisions are elastic in nature because during the collisions, one molecule loses the energy, another molecule gains the energy. So the net energy remains the same. So that collisions are called which one? Elastic collisions. Okay, then after that, another some important points are there. In that, one important thing, gaseous molecules are electrically neutral. Gas molecules are electrically neutral, so they should not, that means they should have no attractions or no repulsions. Among gaseous molecules, no attractions and no repulsions. This is most important point for the next topic in states of matter, that is van der Waal gas equation. This postulate is most important. Okay, another one here, volume is negligible. That means volume of gas molecules occupied is negligible compared with volume of the that original volume occupied by the gas. So the volume occupied by the gas molecules is negligible to the volume occupied by the gas molecules. These two postulates are important for the derivation of van der Waals gas equation. So what is the importance, we will see later. Okay, then after this here, another important postulate also there. What is that means here? That average kinetic energy of gaseous molecules is directly proportional to the absolute temperature. That average kinetic energy directly proportional to absolute temperature. And another point also there here, molecular movements are unaffected by the gravity. That molecular motions are unaffected by the gravity. So these are the important postulates of which one? Kinetic molecular theory of gases. And here that last postulate here, what we have taken last but one, average kinetic energy is directly proportional to absolute temperature. Now let us see what is the formula to calculate kinetic energy. For n number of moles, the formula is 3 by 2 nRT. N is the number of moles, R universal gas constant, T means absolute temperature. So now let us go for one question related to this. So what is the kinetic energy of 2 moles of some any gas? I will give here methane gas. 2 moles of methane gas at 27 degrees centigrade in calories. So we have to calculate kinetic energy in calories. So now the formula here 3 by 2 nRT. So 3 by 2 into n value is what here, that how many moles we have given, 2 moles. So 3 by 2 into 2 into R value in calories is how much, means 2 calories. So 2, and temperature 27 plus 273, we can get 300. 2 and 2 get cancelled, we can get 1800 calories. So this is one of the important questions for any type of examinations. Okay, this is the formula to calculate kinetic energy for n number of moles. For 1 mole of gas, what is the same expression? So as 1 mole is given, therefore kinetic energy equals to 3 by 2 RT. This is for which one? For 1 mole of gas. For example, for 1 molecule, what is kinetic energy is given? For 1 molecule means, we know that universal gas constant value is per mole. That means one, what is one unit here? 2 calorie per degree Kelvin per mole. So now R value is as usual for which one? 1 mole of gaseous molecules. Now if you want to get it for 1 molecule, we have to divide that R value with Avogadro number, because 1 mole of any gas contains Avogadro number of species. So to get for 1 molecule, divide R value with N, and we can get which one? T here. And that R by N, that means here R by N can be taken as Boltzmann constant. What is K means here? Boltzmann constant. What is its definition? Universal gas constant value per 1 molecule is known as Boltzmann constant, and its value is 1.38 into 10 power minus 16 erg per degree Kelvin per mole anuddu. We have to say which one this is, per molecule. And another one, another value also there, 1.38 into 10 power minus 23 joule per degree Kelvin per molecule. Don't say per mole, we have to say it as which one? Per molecule. So this is which one? For 1 molecule kinetic energy formula 3 by 2 kT, where K is known as Boltzmann constant. Okay, then after that, what is here next? Kinetic energy related some other questions also there. What are the questions? Let us see here. If two different gases is given, Ke1 by Ke2 equals to 3 by 2 nRT, in that 3 by 2 and R value are constants, they can be get cancelled. Now what are the remaining here? N1 T1 by N2 T2. So this is the formula to calculate ratio of kinetic energies. Ke1 by Ke2 equals to N1 T1 by N2 T2. Now in this one important thing we have to remember, average kinetic energy depends only on temperature. Irrespective of that number of moles and gas, average kinetic energy directly proportional to absolute temperature, or we can say temperature. But if you want to calculate kinetic energy means, we need to substitute both number of moles and also temperature. Now related to this, what are the questions we get here? Let us see. For example, 2 moles of an ideal gas or any gas exerting what is that 2 calories kinetic energy pressure at 27 degrees centigrade, then What is its kinetic energy value for 4 moles at 327 degrees centigrade? We have to calculate its kinetic energy for 4 moles and at 327. So now substituting in this equation, Ke1 means 2 calories. We have to calculate the second, that means kinetic energy 2 here. N1 means 2 moles. 2 into T1 means 300 Kelvin divided by 4 into 600 Kelvin. So 300 ones are 300 twos are 2 ones are 2 twos are. Therefore, kinetic energy equals to how much you can get 8 calories. So like that, we have to calculate which one here kinetic energy of that gas for 4 moles and at 327 degrees centigrade. So this is regarding which one kinetic molecular theory of gases and calculation of average kinetic energy. And in our next video, let us go for which one real gases. So already we have discussed in this, two postulates are important for the derivation of van der Waals gas equation. So what are that importance? Let us see in our next video. Okay, right, boy.